So we completed till over here, isn't it? We completed like the use of different fields and on, and then how to place, if you place a conducting material, then what happens. And we were talking about dielectrics, a fully filled dielectrics, isn't it? But yesterday I also told you that these dielectrics can also be filled partially, isn't it? So today our topic revolves around that only. Like what happens when the capacitors have partially filled dielectrics. Is that clear or not? So look over here. Let's suppose if I have some kind of a glass a capacitor of thickness or distance d, got it or not? And in this, I placed a dielectric, but not that much thick. It's just present somewhere in between the plates. Are you able to get me or not? Okay. So look over here. Let's suppose the total distance was given as d. Okay. While the thickness of the dielectric slab is given as t. Is that clear? Okay. So I have this dielectric slab of thickness t. Not it. And the distance between the plates is how much? D. So look over here. This is my case 1. When dielectric slab of thickness t where t is less than d is kept. Are you able to get me or not? Now look over here. What is actually happening? You can see that there is some reason between plate 1 and the dielectric slab, and some reason between the plate 2 and the dielectric slab. So here, let's suppose this region is of thickness how much? X1, and this region is of thickness how much? X2, isn't it? Now, if let's suppose if in this region the electric field is E, in this region the electric field will change, and in this region the same electric field will be there now. So this is electric field of air. Here, if the dielectric slab is of dielectric constant K, then here the electric field will be E by K, and here also it is just E, isn't it? Are you able to get me? So now look over here. We know that if this is plus Q and this is minus Q, so electric field due to plus Q and minus Q is what? Simple, Q by A epsilon naught, isn't it or not? And therefore I want to talk about my capacitance. So first we'll talk about the potential, because if I want to talk about capacitance, charges I know it, but I do not know the potential because of this dielectric slab. So in first reason it is what? Q by A epsilon naught into x1, isn't it? Then it will be Q by A K epsilon naught in this reason or not into x2 plus Q by A epsilon naught once again into into thickness T. This is thickness T, not x2. Yeah, is that clear? So now, what is the formula of capacitance? Capacitance is equal to Q is equal to CV, isn't it? So when I put this V over there, C, which is Q by A epsilon naught common, x1 plus x2 plus Q by, I can take 1 minute, let me just do one thing. Let me write this perfectly. I can take Q by A epsilon naught directly common, and this will become just x1 plus x2 plus thickness T by K, isn't it? So then Q and Q got cancelled and I got my capacitance formula. C is equal to how much? A epsilon naught divided by what this will be. This is x1 plus x2. Basically, can I call that x1 plus x2 as nothing but distance d minus thickness t plus t by k. So this can be written as what? A into epsilon naught divided by d minus t common 1 plus, sorry, 1 minus 1 by k. This is the formula of capacitance when the capacitor is partially filled. Are you able to get me or not? Got it? Is that clear? Now this was the derivation, but we can still basically, as you know, that we can still establish a trick for this, and the trick considers like let's suppose this is partially filled, isn't it? So I can consider, and I'm dividing on the basis of distance d. So these all have same potential or not? So can I just consider there are two different capacitors, isn't it? So when you divide on the basis of distance, we get a which kind of connection? Series connection. Which kind of connection? Isn't it? You can you think like or not? Like look over there. If you see them, what is this arrangement? First, I am having one plate, then I am having another plate, then I am having third plate. So I can consider this as series connection or not. Okay. So let's suppose this is C1 means C1 which is there for D minus T, because D minus T the capacitance is same, and for thickness T I have the another capacitance. Are you able to get me? In which the dielectric medium is present. Is that clear or not? So now, so look over here. What is the formula of capacitance if it is in series? 1 by C equivalent is equal to 1 by C1. Let's suppose this is 1. Let me erase. Call this as C1, call this as C2. So 1 by C equivalent is what? 1 by C1 plus 1 by C2. So 1 by C equivalent, for C1 it is simple. Epsilon naught A by D minus T, isn't it? So D minus T will go up and it will become A epsilon naught. Is that clear or not? While this is for thickness T, so thickness T by AK epsilon naught. Is that clear or not? So you can solve it. You see that once again you will get the C equivalent whatever I have got over here as in this formula. Is that clear or not? Are you able to get me? So look over here. Basically this means that C is always equal to epsilon A epsilon naught divided by, yeah, D minus T plus T by K. But this implies that this C is independent of position of dielectric medium or not, isn't it? Is independent of position dielectric slab, because wherever I place it, it just depends upon the thickness T. Is this clear or not? Are you able to get me? Now you know that if the plate will become metallic, this is the normal case of any case of body which I place it as thickness T. If it has constant K, it will become plus T by K. If it is metallic, it will become A epsilon naught by D minus T or not. So simple, because K is infinity for metallic, isn't it? So A epsilon naught by D minus T. Is that clear or not? Okay. Can we move ahead? Write it fast. Okay. Moving to next. Now, this was this placement of the dielectric slab was along the distance d, isn't it? Yes, but I can also divide the area or not. So, next case is dielectric slab placed partially along the length. Is that clear? I place it partially along the length. That means that if this is my plate, okay, then I am dividing on the basis of length. Like I will divide like this way. Got it or not? Okay, so this kind of arrangements are called as dielectric slabs, which are partially filled with respect to length. Got it or not? So look over here. Let's suppose if I have any two plates, okay, and I fill this with a dielectric slab, which is partially placed, means which is placed like this way. Got it? Got it or not? So let's suppose I placed it something like this way. Is that clear? And I want to find the net capacitance. Got it? So this region is basically air or not? And but this region is filled up with some kind of dielectric. Now look over here. Let's suppose this length is d as given. You can see that this is some kind of aerial division. किस तरह का division है ये? Still my electric field inside this region will be what? E by K. And here the electric field will be totally different or not? So I have two electric fields, one E1, another E2. E2, word or not? And if the total length was L, so then this length will be, let's suppose the total length was L. So this length will be L and this will be L minus X. Look over there. This is how I am dividing. Word or not? So this is L minus X and this is X. Word or not? But the breadth of the slab remains same, which is still B. Got it? So let's suppose if I want to find the effective capacitance. So ये किस तरह का distribution? These all are experiencing similar. This one is also at same potential V and this one is also at same potential V or not? Previously they were at different. This one was some another potential. This region was having another potential. This region was having another potential. That's why I called it at series. But here I have the same potential, isn't it? Yeah, so what we can think like this is something like two different capacitors placed in which connection? Parallel connection. Are you able to get me? Got it or not? So now for the parallel capacitors, you know what is the relation? C is equal to C1 plus C2. But you see that if there is a parallel capacitor, then the net charge which was flowing over here will divide into two parts or not. So let's suppose it was Q1, Q, so it will be here Q1, another iron here it will be as Q2. And if it is C1 and it is C2, then I can write the ratio of Q1 by Q2. Q1 by Q2 is equal to specifically C1 by C2. So see, there was a question in NEET 2017 that when we place the dielectric slab in aerial basis, does the charges on the plates on the area wise it is different or same? So the answer is it is totally different. You can see this relation that Q1 by Q2 is equal to C1 by C2, isn't it? And then C equivalent will be written as what? C1 plus C2. This is filled one. Word or not? That one is air. So C1 is how much? Epsilon naught. What I will write? It will be written as epsilon naught, and this is I'm calling as C1. Just call it as this one is C1, and this is C2. So its area will be how much? Area will be L minus of x into breadth B, isn't it? So A epsilon naught by D or not. So this will be my formula. Second case, this will be K epsilon naught x divided by distance. Uh-huh. What? What you say? L. Why L? So other one is okay. Let me change because one is x. Sorry, one is x. Another one is L minus x. 1 minute. 1 minute. There is someone on the door. Okay. Just 1 minute. Okay. Hello. Can you hear me? Yeah, so this is L minus x, this is how much? X. So K epsilon naught into how much? This will be x into B divided by distance D. Is that clear? So this is my C equivalent. So now what I can write it as C equivalent? Then I can write it as C equivalent is, yeah, so basically I can take B common, isn't it? So B epsilon naught by D, and it will become K minus 1 into x plus length L. This will be my equation, isn't it? So you just put this areal length, you just try to put this area and you will definitely get the answers. Is that clear or not? Isn't it? So look over here. Now next important thing to notice over here in this kind of connection, that let's suppose if this is sigma 1, then this will be at sigma 2. Sorry, this will be minus of sigma 1, isn't it? And here if it is sigma 2, then this will be minus of sigma 2, isn't it? But whatever happens, the particular, let's suppose if I write the electric field equation, so E1 will exactly equal to E2, which will be exactly equal to potential by distance D or not. So previous case, the electric field used to change, but here E1 and E2 are what? Same. When you do the which kind of division? Areal division, because the change in potential difference between two equipotential surfaces is also same. Is that clear? Are you able to get me? So what is E1? E1 is nothing but sigma 1 by twice epsilon naught, isn't it? No. I'm tell just epsilon naught because I'm taking total electric field. Okay. And second one will be how much? Sigma 2 by K epsilon naught. Yeah, so this implies that I got the ratio of sigma 1 by sigma 2, which is exactly equal to how much? 1 by K also. Are you able to get me or not? So charge density in this plate is how much times reduced? 1 by k times it is reduced. Is that clear? Are you able to get me? So you'll see that in this kind of capacitors, our electric field is same, but the sorry, charge density is different on different plates. Okay? Are you able to get me? So we got to know about the first case, second case. Similarly, you can write the E1 and E2 for another cases also, isn't it? And let's suppose if in this, if it would have been also filled with some another dielectric, you can write sigma 1 by k1 epsilon naught is equal to sigma 2 by k2 epsilon naught or not. So you should have also got that sigma 1 and sigma 2. Is that clear? So the major conclusion is that when I divide on the thickness basis, means on the D basis, it is an series connection. Which kind of connection this is? Series. And when you do the aerial division, it is which kind of a connection? Parallel. And this is the most important consideration which we have to always take into consideration. Is that clear? Okay, can we move ahead? Okay, so let us do some problem, then we'll move ahead. So first question, let's see what it is saying. Find the capacitance across terminal A and B. Okay, this is A and this is B. Okay, uh, area of each plate is A. Okay, so let me means I have to find the capacitance only now. So do it. Let me take this first question in a good pace, big pace. Okay. So you have to find the capacitance where distance is D and area of each plate is A, and I have to take into consideration that value of C is given as A epsilon naught AK epsilon naught by D. Are you able to get me? Do it. So if, first of all, it's a series or parallel connection. So ST series connection because the potentials are different, isn't it? So this is point A, this is point B, this is C1, this is C2. Got it or not? So just apply. Just do not think of the formula right now. That formula was for derivation. So just write 1 by C equivalent is 1 by C1 plus 1 by C2. 1 by C1 will be how much? Like it will be 1 by epsilon naught S by A epsilon naught into thrice K or not? Yes, isn't it? 1 minute, I'll tell you. What is C1? 3K A epsilon naught divided by how much? Distance is D by 2. Yeah, so C2 will be how much? C2 will be 6K A epsilon naught divided by D by 2, isn't it? So your equations will become what? It will become D on the numerator, and this is 6Ka epsilon naught plus D by 12Ka epsilon naught, isn't it? So I can take D by K epsilon naught common, 1 by 6 plus 1 by 12. So 1 by C equivalent is how much? This is D by K epsilon naught is 1 by C. So 1 by C, and this will be how much? 2 plus 3. So 3 by 12. So that means C equivalent is how much? 4C or 4 Ka epsilon naught by D. Are you able to get me or not? Is that perfectly clear? Got the idea? What is the value? 4 Ka epsilon naught by how much? D. Is that clear or not? Can you do the second one? Yeah. This is in which kind of connection? Parallel connection. Tuesday we will do current, okay, and we will save two more topics of capacitors, two more lectures of capacitors after the exam, okay. So from when to when is your exams? 20 to 29. At that time the classes will be there or not? Okay. And after that, when we'll have our classes? Okay, okay, okay. Yeah, that's the area only, na? So this time, yeah, I have two parallel capacitors, isn't it? Heard or not? And let's suppose this is C1 and this is how much? C2. So what will be the value of C1? This is 3K. So 3K A epsilon naught. But area is how much? A by 3. Area is how much? A by 3. And divided by distance is given D. Heard or not? So this becomes how much? Ka epsilon naught by D. Similarly, C2 is how much? 6K into twice A by 3 epsilon naught by distance D. So how much is that? This is 4 Ka epsilon naught by. So C equivalent is how much? C equivalent is C1 plus C2. How much is that then? 5 Ka epsilon naught by distance D. And this is what? C. So answer is 5C. Got it or not? So now you got the idea, no? That if you do the aerial division and if you do the lengthwise division, you have two different cases. Aerial division is a parallel connection, and thickness division is a which kind of a connection? Series connection. Are you able to get me? Do these two problems then. 3 and 4. And then do this. बताओ क्या होगा? It's you have to do very very fast. Hmm. Should I help? Okay, the first one is a how many kinds of connection? These two are in series and this is in parallel or not? So how I will draw? I will draw like one capacitor is in parallel with the other two capacitors which are in series. Correct? So you got your answer that this is call it as C1, C2, C3. Then first thing is C1. C1 is I call this as C1, this is C2 and this is what? C3. So C1 is how much? Epsilon naught 8k A by 2 epsilon naught by distance d, isn't it? So 4c basically because k epsilon naught once again our constant reference is k a epsilon naught by d is my c. Are you able to get me or not? Similarly, C2 is how much? 3k. So this time area is how much? It is in the area A by 2 only or not? So it is 3k A by 2 epsilon naught, but there is also D by 2 also. So this is how much? This is exactly equal to how much? 3c, isn't it? Yeah, I'm solving for third one. Then C3 is how much? Similarly, 6k epsilon naught A by 2 divided by d. So 6c. 3c and 6c are in parallel. So what I will be writing as C equivalent. C equivalent is nothing. Sorry, series. So it will be 4c into 3c into 6c divided by 3c plus 6c or not. So C equivalent is how much? 18 divided by 9. So 4c plus 2c which is 6c. Is that clear? Got it or not? So this was the answer of what? Third one. Can I do is even the fourth one? Okay. So for fourth one, what will be the equation? And see, this one is in series, and two are in parallel. No, the first one I start with series, okay, and another two are in which connection? With them parallel connection. So what will be the diagram of this? Uh, kind of this diagram, isn't it? Are you able to get me or not? Is that clear? So once again, let's suppose I call this as C1, C2, C3. So this is C1, C2, C3. So C1 is how much? 6K, area is same, epsilon naught D by 2. That is means 12C, isn't it? C2 is how much? 12K. Area becomes also half epsilon naught and D by 2. Once again, this is how much? 12C. Got it or not? C3 is how much? 3K. K by 2 epsilon naught divided by how much? D by 2. So this is how much? 3C. Are you able to get me or not? 12C and 3C are in series, parallel. So they become how much? 15. So in fourth case, C equivalent is how much? It will be 15 into 12, 15C into 12C divided by 15C plus 12C, isn't it? So how much is this? You just do it. 15 into 12 divided by 27, isn't it? So this is how much? 3 nines are 27, no? 3 fives are 15. 4 and 3. So 20C by 3. This is your answer in the fourth case. What? We took the series. Wow, wow, yay. C1 plus C2, they are in parallel or not? Then only I'm considering them. Okay, and then these two are in series. Then I'm considering the C equivalent. Okay, got it? Okay, can I move ahead? Okay, now let us consider your test is on 20th directly, isn't it? So we are considering current electricity. Can you just share me the notes of your school teachers, what they have done in current electricity and how much they are asking in current electricity? Any idea is there? They are in Kirchhoff's law. Yeah. So did they told like what they will ask? Okay, that's too much easy. Okay. They have taught drift velocity and all? They didn't have taught drift velocity. You you share me the notes basically. I'll have to check what they are going to ask. Okay. So they have done only Kirchhoff's law. So if I teach you first like the series connection and parallel connection and the Kirchhoff's law and then drift velocity and all. So can you just make the notes perfectly? Okay, so the Monday lecture I'll teach you Kirchhoff's law and series and parallel different kinds of connections basically. Is that clear? And the color coding and the resistance and all that we will do on Tuesday. I'll teach you this. So that thing we'll do later. So when I'll start current electricity, you leave first 15 pages of the notes, okay, and then you start making the notes which I'll tell you. ठीक है? Okay. Okay, so बोल रहा है, let us see one more question. This is a very nice question. It has a very good explanation. That let's suppose I fill these capacitance plates with some kind of a capacitor, but here one thing is given that from here to here, going from here to here, the dielectric constant it is not a constant term. This dielectric is depending upon the length x, which is given as alpha x plus beta. Right or not? Okay, where x is, let's suppose some distance from one end of the plate. Is that clear or not? Then question is find the capacitance between A and B. Where area is A, if the total area is A, and the distance is how much? B. Got it? Yeah. So I'll write it in down. 1 minute. So here K is varying as alpha x plus beta. Okay. Then you have to find the capacitance. बताओ कैसे निकलेगा? Oh, should I do or can you do? Yeah, it involves integration. Of course, anything which is path dependent will involve integration, isn't it? Should I help? What can you do? Do it fast. Think, analyze. You can do it. मुन्ना बड़ा प्यारा मम्मी का दुलारा. Okay, let us see. So here, what we will have to do? Here the K is varying with respect to length, isn't it? So I'll have to consider a very small strip of length dx and then it find its capacitance and integrate over whole region or not, because this K is not varying with respect to area, isn't it? So let's suppose I consider a very small length which is dx, its capacitance is how much? Dc. Okay. So dc will be what? I can write the formula of dc. Dc is equal to k area is very small. Sorry, area is say A into epsilon naught divided by how much? Dx. That's my DC, isn't it? So what I can get it over here? I can get it like z z z z Eisenstein which is alpha x plus beta into a epsilon naught divided by dx, isn't it? Now this is some kind of unorthodox integration, isn't it? So there is a process to do it. We can write it as 1 by dc or not, and that will be changed to integral dx by alpha x plus beta a epsilon naught. Is that clear or not? And 1 by dc integral can be written as 1 by c. Yes, because dc is what? Just c, got it or not? So that's why I can do it like this way, but it's not accurate, it's not correct actually, got it or not? So 1 by c is equal to integral dx. So 1 by a epsilon naught will be common, and this is looking like 1 by x dx form or not? Do you know this integration or should I teach you? So it is what? ln x is how much? Alpha x plus beta. And with the x, there is a coefficient over there or not? So it must be divided also. Is that clear or not? Are you able to get me in this? 1 minute. Alpha x plus beta. 1 minute. I think इसको ऐसा मत करो, बट चेक कर लेते हैं क्या आता है. Consider 1 by c is equal to integral whatever it is. So let us just consider alpha x plus beta as u, right or not? So can I write alpha into dx बराबर du, isn't it? क्योंकि बीटा तो जीरो हो जाएगा ना. Beta is a constant term or not, so its differentiation will become how much? Zero. Got it. Got it. No. We'll have to put the limits also. We'll have to change the limits in that sense. So this will become what? Integral dx is du by alpha. So 1 by, I can write it as 1 by alpha a epsilon naught common integral du by u, basically, which I have considered, isn't it? But when x was equal to 0, when x is equal to 0, u is equal to how much? This is from 0 to distance d, isn't it? So when x was 0, u was beta, isn't it? And ultimately at some distance x, means at x is equal to d, this u will become how much? Alpha d plus beta. Are you able to get me? So the integration must be taken from in terms of u beta to alpha d plus beta. Are you able to get me or not? So this means that I will get 1 by c is equal to 1 by alpha a epsilon naught due by u means ln u. Ln u means this is alpha d plus beta divided by, I can write beta or not directly because this will come as what? This thing will come as ln u beta to alpha d plus beta, isn't it? So that's why I can write log a minus log b as log a by b. Are you able to get me or not? So I got my c value, that c is nothing. It is alpha a epsilon naught divided by ln alpha d plus beta divided by how much? Beta. Is that clear? Are you able to get me? Same kind of question, same kind of problem, but this time if I fill the dielectric, Then what has happened is this time in this dielectric, this time the K is varying in upward direction. In which direction? Means K is varying in terms of length. Are you able to get me or not? So at any distance x, the value of K is given as alpha x plus beta. Is that clear? Then question is once again, find the capacitance between A and B. If the net distance is D and area is A. Do it. It's an awesome question. It will require a lot of concept to understand this. ना बड़ा प्यारा बताओ क्या होगा आंसर it's varying along the length of the area. So how I'll consider the some kind of element? I'll have to consider this kind of element, isn't it? And you saw that its breadth is still same, but a length is varying, isn't it? So it's looking like this way. Remember that it's the strip. This aerial variation is something like this. Okay, that's why. Okay, this is the kind of strip we are considering. So look over here. Its breadth is still what? Same, but length is dy. अच्छा x पे vary करना ना? So dx. Why not? At some distance x from the base of the plate. Is that clear? Once again, when you write dc, dc will be what? Ka. So here K will be K into area is what? Breadth into, for the strip it is just dx, isn't it? So KB into dx epsilon naught by distance how much? D. Is that clear? Because DC is written as what? Simple K dA epsilon naught by distance D. Is that clear? Are you able to get me? So DC will be what? K is given alpha x plus beta into B dx epsilon naught by how much? D. Is that clear or not? Integrate कर दो है ना? Yes. So basically this implies C is equal to, I can take B by D epsilon net common integration alpha x plus beta into dx, and that is taken from 0 to length L, isn't it? Are you able to get me? So C is equal to B D epsilon naught by D. This will become alpha x square. So alpha L square by 2 plus beta. This is my net capacitance. Are you able to get me or not? So I can just multiply. I can just multiply. I can write this C as. Let us take L common. So C, it will become what? L into B means area A epsilon naught by how much? D into alpha L by 2, alpha L by 2 plus beta. Are you able to get me or not? Is that clear? So, ma'am. So this was about your variation of capacitance through the help of areal length and all. Is that clear or not? ठीक है? So today I told you that I'll take 1 hour of class, isn't it? Sorry, 2 hours of class. So, 1 hour right now I'm taking, and in night also I'll take. You practice all those questions and doubts, and then the doubts also and the charging and heat through the capacitor. One more class I'll take at that time. Is that clear? Because that is a totally different topic. Are you able to get me or not? 9:30. 9:40. Night class.